Hi everyone, it is Sri Devi, Professor of Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about coherent communication with waveforms in matched filter. Characteristics. On completion of this video lecture, the learners can be able to understand the matched filter for ISI elimination. So matched filter is nothing but a receiving filter. The purpose of using matched filter is to maximize the signal to noise ratio. It is used as a receiving filter for baseband and passband filters, hence it is a receiving filter. The SNR defined as signal to noise ratio. The peak signal peak instantaneous output signal power to the root mean square output noise power. So this peak signal to noise ratio is increased by using this matched filter. Matched filter is an optimal linear filter for maximizing the signal to noise ratio. So in all type of electronics and communication systems, for communication purpose, matched filter is very important one. Matched filters are commonly used in radar, in which the signal is sent out. So the signal is sent to the radar, and we can measure the reflected signals looking for something similar to what we sent out. So two-dimensional matched filters are commonly used in image processing. So example, it is used to improve the SNR of X-ray pictures. So this is the block diagram of matched filter. We know that the matched filter is used for the detection of signals in baseband and passband transmission. So the transmitted signal and the received noisy signal is transmitted and via transmitter, and the noisy signal is received in the receiver. So here the input signal is G of t with white noise W of t added together, G of t plus W of t, that is X of t, given via one linear time invariant filter of impulse response H of t. After passing this, the output Y of t is given as the switch, and it is sampled at instant of time small t is equal to capital T. The filter input X of t consists of pulse signal G of t corrupted by adaptive Gaussian channel noise W of t, and it is shown as we said X of t equal to G of t plus W of t, where small t lies in between 0 to capital T, where capital T is the arbitrary observation interval. The pulse signal G of t may represent a binary symbol 1 or 0 in the digital communication. The W of t is the sample function of white noise process of zero mean and power spectral density N0 by 2. N0 is the power spectral density of white noise. The function of the receiver is to detect the pulse signal G of t on an optimal filter given in the received signal. We can take the decision in the decision criteria. So whenever noise is absent and whenever noise is present. So when noise is absent, R of t, received signal R of t equal to x01 of t, and x of t equal to x1 of t, and R of t equal to x02 of t when x of t equal to x2 of t. When noise is present, it is called as x1 of t is selected if R of t is closer to x01 of t than x0 of t, and x2 of t is chosen when R of t is closer to x0 of t than x01 of t. So matched filters are commonly used in radar, and we said that we are waiting for the signal which is sent. So it is also called because of impulse responses of matched filter to input pulse signals. Two-dimensional matched filters are commonly used in X-ray image processing, and the error rate of matched filter is comparatively better, and it produces better signal to noise ratio, and it uses Square's inequality theorem The minimum error probability of matched filter P of E equal to 1 by 2 into error function of root of E by N naught. The transfer function of matched filter H of f equal to 2k divided by N naught into x star of f into e power minus j 2 pi into t. Here we have one quiz question based upon matched filter. Matched filter may be optimally used for Gaussian noise, transit time noise, flicker noise and all above. As we said earlier, the answer is A. Matched filter is used for Gaussian noise only. Thank you.